there is a pentagon and then all the measurements are correct to nearest cm, so it may not be the true value, but it's within a certain range. 5 may be between 4.5 to 5.5. 6 between 5.5 to 6. After that, they find the actual area of the pentagon. We have to find the range of the values. We just simply use the basic strategy to separate the maximum case, the minimum case, and then compare with the boundary here. But you find that all of them are different, so which means that you just need to get, for example, maximum case value, then you can sort out the answer. But this one is a little bit tricky. Let us consider the maximum case, maximum area. Our method is to separate the area into two parts, two shapes. The first one is a rectangle, and then the second one is the trapezium. We are going to choose the largest value. We get 6.5 here, and then we have 6.5 and 3.5 here. But the only tricky thing is about this 2. 5 here is included in 10. That means for this length, if we choose 5.5, then this part will be shortened. We have to determine how should we allocate those 0.5 cm area. Should I put it here to create a larger shape, or should I put it here to create a larger shape? In order to get the maximum area, of course we should allocate the 0.5 area into the full rectangle rather than just a trapezium, because some area are wasted in the space here. So therefore we make our decision, we should allocate this part is 5.5 cm. Therefore, even though the total length of Q out is 10.5 cm, then the rest will be 5 cm only. This is the maximum area case, then we can now get the area. Rectangle 6.5 times 5.5. For trapezium, it's 1/2 upper base plus lower base times the height. We get 60.75. So the answer is B. If you do not fully understand why we add 0.5 in the rectangle rather than the trapezium, if we consider the extra part for 0.5, then this part 0.5 will give you this extra space only. This is no difference at all, but this is just a triangle. However, in left hand side in the rectangle, we have the full rectangle, which do not need to divide by 2. That's why allocate those 0.5 into the rectangle is more efficient than putting in the trapezium.